Hi class, this is Dr. Karsten, and today we are doing Lesson 13 from Module 5, Grade 4 of EngageNY Math. And in today's lesson, we are once again going to be using benchmarks to be comparing fractions of different sizes, but today's fractions are actually going to be fractions greater than 1. So let's really quickly talk about what is a fraction greater than 1. And I know that we did these earlier in this module, but for example, 5/3 is a fraction greater than 1, and we know this because the numerator is larger than the denominator. Remember that the denominator represents the number of pieces that one whole will be cut up into, but this is going to be greater than one whole. This is the number of pieces that we have. So let's talk about how we can kind of work with a fraction greater than 1. So for example, if I have this 5/3, what I could do is I could pull out one whole out of this. And how would I do that? Well, I'm going to pull 3/3 out. And the way I know that I'm pulling out 3/3 is because I know that 3/3 is equal to a whole. When my numerator and my denominator match, that's actually just equal to 1. So now remember, when we're adding or subtracting fractions that have the same denominator, which I'm telling you we have, I can actually just add or subtract the numerators. So what I can say is that 5/3 minus 3/3 is going to give me 2/3, or 5 minus 3 is 2. 3/3 plus 2/3 gives me my 5/3 back. So now what I know is that this 5/3 is actually equal to 1 and 2/3. So I just took my 3/3, I turned it into a 1 to show that 5/3 is really just 1 and 2/3. Okay, so let's model this in two different ways. Let's start with a tape diagram because those are always nice and easy and they make a lot of sense for you guys. And so I'm going to go ahead and draw myself a tape diagram. And for this tape diagram, I'm going to say that that is going to be about where one whole is. Because again, it's a fraction greater than 1, so I need to be able to model that this is more than 1. And then I'm going to first show these 3/3. Now remember, my denominator is 3, so my one whole is going to be split up or divided into 3 equal parts or units. So there's 3 units in this one. But now I need to go beyond that, so I have 1, and I need 2/3 more. So now what you can see is that I have one whole, and I have 2/3 more, because each one of these parts or units or pieces is equal to a third. Okay, let's now go ahead and let's model that or draw that on a number line. So like we've been learning, I'm going to put in my benchmark of 0, and now I'm going to put in a benchmark of 1, and then I'm going to go ahead and add in my benchmark for 2. So these are the benchmarks I'm going to use right now. Today we're also going to be using our halves, but for this problem I don't need to do that. So remember that 0 could be also written as 0/3 if I want to start talking about it. Ooh, let me move this up. Sorry guys. That 0 could just be talked about as 0/3 since I'm working with thirds, because I was working with 5/3. Remember that 1 can just be explained as being 3/3 or written as 3/3 because 3/3 is equivalent to 1, numerator, denominator match. And then, not that we're going to have to do this today, but I actually could have gone up to 2 and written that in terms of thirds. But there's only one problem in the problem set, and it's like one of the very last ones that deals with going up to 2 or over. Otherwise, we're sticking with fractions greater than 1. They will not exceed or go beyond 2. Okay, so now I've modeled so far my one whole. Let's go ahead and figure out, or let me put in these thirds. So I would have 1/3, 2/3, one whole here because it's 3/3. And now I could put in 4/3 and 5/3. So right here is where I have one whole and then 2/3. Or the other way to write that would be to say 1, 2, 3, 4, 5/3. Okay, so these are the ways that we are going to be looking at fractions. We're going to be able to take a fraction greater than 1. We're going to be able to pull it apart into 1 and some other fractional part. So in this case, 5/3 is 1 and 2/3. We could model it with a tape diagram, or what we're really going to think about are our number lines. Let's do another example, but this time we're going to end up comparing two different fractions. So let me just move this one aside. I'm a little nervous about pausing. I already had one major glitch this evening where I lost basically the whole video. I think I need to contact the company about this new camera because it is really starting to give me problems. So let's take a look at 5/4. So if I wanted to look at the fraction 5/4 and put it on a number line, the first thing that I want you to think about is, how can I split that apart? I want to split it apart into fourths, and I want to try and make a whole out of that. Remember, for fourths, a whole would be 4/4. Do I have enough to pull 4/4 out? I do. I have 5/4. So I can pull out that 4/4, and then 5 minus 4 would leave me with 1/4, because I have 5/4 minus 4/4 is 1/4, or 4/4 plus 1/4 is 5/4. Now another way to write 5/4 would be to take this whole and write that as 1, and then I also have my fourth, so 1 and a fourth, and that's a nice mixed number. Let's go ahead and let's draw that on our number line. So I'm going to go ahead and give us a nice long number line that we can work on. And I'm going to put my benchmarks in again. So I'm going to put my 0 in, I'm going to put my 1 in, and I'm going to go ahead and put my 2 in. So those are my benchmarks for right now. And really, to make those super clear, because I'm going to be drawing other things on here, I'm going to just circle those so that we don't lose them as we are doing our work. So now, let's think about where would that 5/4 fall on this number line. Well, I know that another way I could think of that 1 would be as my 4/4. So I know that this part of it, the 1 whole, I can either bring it to 1, or I could say that would be 4/4. Now I need to add on 1/4 more. Where would 1/4 fall here on this number line between 1 and 2? I have 1, now I need that fourth. And you can kind of think about this the way we did yesterday, where remember we were working with like going from 0 to 1? Well, now we're going from 1 to 2, but we're still doing the same thing. I could think of this as being split up into fourths. So I'd have 1, and then 1/4, 2/4, 3/4, 4/4 would get me to 2 again. So I know that 1 and 1/4 is going to be right here, and I'm going to go ahead and write that. So I would have, I'm going to write it as 5/4, or 1 and 1/4. So it would fall right around here, and I could actually write in my fourths on this side if I wanted to. So now you see I have 1/4, 2/4, 3/4, 4/4, 5/4, or 1 and a fourth. So those are my two ways of writing this. So now let's think about another fraction. So let me just kind of split this in half, and let's say that we're doing 7/6 is going to be my other fraction that I want to compare 5/4 to, using my benchmarks again. So let's do the same process. I have 7/6. I want to pull a whole out of this, but now my denominator is 6. So I know that 1 whole would be 6/6. And that would again leave me with 1 more. So if I pull 7/6 minus 6/6, that's going to leave me with 1/6. Or 6/6 plus 1/6 is 7/6. So now I can say that 7/6 is really equal to 1 and a 6th. So that would be another way of writing 7/6. So now I need to put that on my number line. And I need to think about where is that 1/6 going to fall on this number line. Because I know that I have 1 whole, I can see that right there. But is 1/6 going to be less than a fourth? Is it going to be more than a fourth? Where would that fall? Well, let's remember what we know about fractions. I'm going to slide this up, and let's just kind of think about what 1/4 and 1/6 mean. let's compare them. So 1/4 and 1/6. Now, what I know is that when my denominator is a smaller number, 4 is smaller than 6, that then these pieces are a lot bigger. But when my denominator is smaller and 6 is smaller than 4, my pieces are a lot smaller. Let's sketch that out just to make sure that that's clear. Let me do 2 quick tape diagrams. And let me model out 4ths for us. And then let me model the 6th for us. And if I were to fill in 1/4 or shade it in, because the numerator is what we have, let me shade in 1/4 and let me shade in 1/6. Now it becomes really clear, and you can see that 1/6 is a lot smaller than a 4th. So if I have 1 and a 4th, so I have 1 and a 4th, that's going to be farther along or farther away from this one than 1 and a 6, because 1/6 is only going to get us a little bit of the way. So I'm going to go ahead and mark that 6th as being about here. And so I could write that this is 7/6, or that this is 1 and 1/6. So again, I have 1 and then that's 6. So now if I wanted to kind of talk about what's greater and smaller, I have my 7/6, I have my 5/4. If I look at them here, I can see 7/6 is less than or smaller than 5/4. And then I could also write it as the mixed numbers. 1 and 1/6 is less than 1 and a 4th. Okay, so because I am really nervous about this video, no, you know what, let's push through and let's do the first problem. So let's keep going and see how it goes when you jump into the problem set. Okay, so let's take a look at the first problem in the problem set for today. So here we go. So this is our problem set. And again, we're in Lesson 13, and we're back into our problem sets. We're not doing homework right now, we're doing the problem set. And let's take a look at this first problem. It says, place the following fractions on the number line given. So the first fraction that I have to work with is 4/3. So I need to figure out where I'm going to put 4/3 on this number line. I just realized I'd never put on the light. This might actually be helpful for us if I turn the light on like that. Okay, so what I want to do is I'm going to move this 4/3 up here to work with it. And I'm going to say that 4/3, remember we want to kind of pull out any whole holes in there. So like 3/3, because my denominator is 3. And sure enough, 4/3 is definitely a fraction greater than 1. My numerator is larger than my denominator. So I can pull out 3/3, and that would leave me with 1/3, because 3 plus 1 is 4. My denominator is the same. So now what I know is that 4/3 is actually equal to 1 and a 1/3. So now I can try and put this on our number line. Now I don't know if you noticed on this number line, but on this number line, our benchmarks, our reference points are 1, 1.5, and 2. So since these are 1, 1.5, and 2, we're not starting with the zeros. We're starting right into this 1. So all I really have to worry about is that 1/3, and I have to think about where does the 1/3 fall on the number line. Now, I don't know if you guys remember, I did a lot of this with thirds and fifths, but that we need to keep in mind that if I have a number line, and I had 0 and 1, that 1/3 is not going to fall, and you can compare it, or it's not, sorry, that thirds do not have a half equivalence. So 1/3 is between 0 and 1/2, this is 1/2, and it's closer to the half. 2/3 falls between 1/2 and 1, and it's closer to the half. So keep that in mind. Oh, I just realized I didn't do a very good job with that. I'm so sorry. So again, if I drew my thirds, and I can show you where, sorry, my computer was about to shut down. Not shut down, but the video was going to not be there, so I had to click it. Anyway, So again, if I drew my thirds out on this number line, we can see that 1/3 is between 0 and 1/2, but it's closer to 1/2, and that 2/3 is between 1/2 and 1, and it's closer to that 1/2 again. So if I were to have to think about where to place 1 and 1/3, if I thought about this number line being divided into thirds, I would say they're right about there. That looks like about 1/3, 2/3, 3/3. So I'm going to go ahead and mark that right here. And I'm going to go ahead and say that that looks to me to be about 4/3. Or, oh, and I totally just messed that up, guys. And I am so sorry. It's late. I had the glitch. I'm running an hour behind schedule. So ignore that. 1 and 1/3 would fall about here on the other side, after I just showed you on this piece of paper that it would be on the left side of the 1/2. So sorry. So I'm glad I caught it though. So we're going to put our 4/3 right here, and I'm going to write the fraction 4/3 here, and on the bottom I'm going to write 1 and 1/3. So again, we have 1 whole, so that's that 1 whole plus that third, so that's the 3/3, and then we have another third on there. So now let's work with 11/6. So I have 11/6, and let's see, what could I split that into? Well, again, I can pull 6/6 out. So then 11 minus 6/6, 11/6 minus 6/6 will give me 5/6, because 11 minus 6 is 5. And they're just all 6. That's like the label almost. So 11/6 minus 6/6 is 5/6. Okay, so given that 11/6 minus 6/6 is 5/6, what I can do is I can say that this is 1, 6/6 is 1, so this is equal to 1 and 5/6. Well, I'm looking at that, and I know that 5/6 is almost 6/6. So it's going to be really close to this 2. So I'm going to have 1. Remember, there's a whole lot over here. I have 1. And then 5/6 is going to land me somewhere close to, like, I don't know, around, I would say right around here. So that's going to be 11/6, or the other way of writing it is 1 and 5/6. Okay, so now we just have one more fraction to deal with, and that's 17/12. So let's take our 17/12, let's do the same thing. I can pull 12/12 out of that, which is equal to 1 whole. And then I would have 5/12 left, because 17/12 minus 12/12 is 5/12, or 17 minus 12 is 5. Again, like denominators, I can do that. So now what I know is I have 1 whole and 5/12. So where am I going to put that on this number line? Well, I have my 1, so now I just have to deal with this 5/12. Well, what I know is that 6 is half of 12, so 6/12 would be right here. So 5/12 is going to be pretty close to 6/12. After all, 12ths are pretty small. It's going to be 1/12 less than 6/12. So I'm going to put that right about here. So that's 1 and 5/12, or 17/12. I'm going to write 1 and 5/12 also. So now we have placed these on our number line. Now we can use that to answer the question number 2. So if I take a look at